Hi, my name is Matthew McGuff, and this is our group's presentation fulfilling requirements for CS 416 at BYUI. Today we'll be discussing integration and system testing. We'll be going over what it is, how to do it properly, upsides, downsides, and when it is most effective. So let's begin. What is integration and system testing? Applications are broken up into parts or modules. Consider the following illustration of a software system. As we all know, software systems are comprised of many components. In enterprise-level applications, it's not uncommon for several modules of a system to be developed by different people. Integration testing focuses on how these components work together or integrate with one another. All the components of a system come together to solve a problem or serve some purpose. System testing focuses on ensuring that a given system is solving its intended problem or purpose. A more specific definition given to us from Maverick Systems defines system integrated testing as testing that ensures that individual modules, product setups, batch operations, basic reporting functionality, and key interfaces of an application under test work well. Integration testing deals with testing various software modules, first individually, then together. It's especially important that we perform integration testing as we hook up various modules to ensure that data integrity is not lost as the modules communicate with one another. When we are integration testing, we can use one of the three techniques: Big Bang integration, top-bottom integration, or bottom-to-top integration. The Big Bang integration testing takes place when a tester combines all the modules together first and then performs a test on them. The top-bottom integration testing, the tester uses test stubs or test modules beginning with the topmost module. A test stub refers to a program that simulates a module that the target module depends upon. The third technique is bottom-to-top integration testing, which is similar to top-to-bottom integration testing. However, it uses test drivers instead of test stubs. Drivers work similar to test stubs in that they simulate a module that is calling upon the module being tested. With bottom-to-top integration testing, we test the lowest module first. The objective of integration testing is to ensure that modules being developed by individual developers work together when combined. This allows the testers to find any defects or bugs in the interface as a result of possible corruption of data as it transfers between modules. So let's discuss system testing. System testing takes place when we test the system with all of its components connected, and always takes place after the system integration testing is completed. The tester can choose to conduct system testing by a functional test or a non-functional testing approach. In a functional testing approach, the tester ensures that each software meets the functional requirements. The tester may do this by providing input to each function of the system and ensuring that the output conforms to what is expected. In non-functional testing, the tester ensures that software meets the non-functional requirements. The tester may do this in many ways, such as testing the system's performance, endurance, security, usability, and so on. The objective of system testing is to ensure that the software meets the criteria specified in the software requirement specification, to find any bugs or defects that arose as a result of combining all the modules, and to perform tests that center on an end-to-end perspective from the user. So, let's talk about some upsides to integration and system testing. As system testing focuses on the system as a whole, system testing allows test engineers to see the product meets the requirements of a client in the software requirements specification. It also allows engineers to see how the system would perform in a real-life scenario. This in turn lets the test engineers decide if the product really fits the needs of the client or if there's something that needs to be changed in order for the client to be satisfied. System testing is also useful because sometimes there are bugs that do not show up until all system modules are combined as a whole. Integration testing is more focused on the interactions between individual modules. So This means that any defects that are uncovered in this process are traceable to one of the tests, which makes them much easier to find and fix. Integration testing also allows the test engineers to see what data is being passed from module to module, if each module is compatible with the others, and if each module is compatible with any third-party tools that are in use. With the overall focus of system testing and the narrowed specific focus on integration testing, the two types of testing work in tandem to complement one another. Since integration testing is usually done first, many of the bugs and defects are already discovered before system testing even begins, leaving only the bugs that surface when the entire system is being tested. Then the system test can be completed to let the engineers see just how well the system as a whole fills the client's requirements. In other words, the two of them work together to validate that all parts and modules of a system are working together to fulfill system requirements. Still, even combining these two techniques is not perfect. Since system testing is a form of black box testing, it doesn't necessarily find every bug the system may contain. In fact, in order to find every defect, a test case would have to be written to execute every possible situation or combination of input from a user. Even in a simple system, this is not generally considered a feasible task. As also many test cases already are used, the integration testing might be repeated in the system testing phase, thus testing cases redundantly waste time. As for integration testing, there are several possible weaknesses depending on the exact integration testing being employed by the engineer. The technique known as Big Bang testing, where all the modules interact all at once, can make it hard to find the exact location a bug is occurring. The technique known as bottom-up testing for low-level modules first might leave higher, more critical modules untested. Finally, the top-down approach might also leave modules to be untested. Despite the best efforts of developers and testers, broken software still remains an extremely costly problem. According to the U.S. National Institute of Standards of Technology, $60 billion each year is spent patching broken software. This number represents a lot of unhappy people, including users, developers, and stakeholders. One final thought on software testing. Testers don't like to break things. They like to dispel the illusion that things work. And this brings me to my final point. Testing software is everyone's responsibility. It's not just the responsibility of QA alone. Brothers and sisters, this is our craft. Let's be anxiously engaged in a good cause in delivering a high-quality software product, one that we're proud of and that is free of defects. Let's go forth and ensure that when we're delivering our software product, that we've thoroughly tested it, testing the connections of how they interact with one another, and ensuring that that the software that we're delivering meets the requirements that they should. I'm Matthew McGuff. Thanks for watching.